So when we're talking about the idea of electronegativity, essentially what we're talking about is the ability for an atom to attract electron density from another atom. So it's just a measure of how much does one given atom want to pull away electron density from, let's say, an adjacent atom. So it's actually very related to what we're talking about when we said electron affinity, and it's also related to ionization energy. And we can call electronegativity by a symbol here, and it turns out that it's going to be proportional to 1/2 of the electron affinity of a given atom plus the ionization energy. So in other words, we can just think of electronegativity as being the average of that ionization energy and the electron affinity. This should make sense because if an atom has a very high electron affinity, that means it's really happy taking an electron from another atom or taking a free electron, that's very favorable. If something has a high ionization energy, it means that it really, really, really does not want to give up an electron. So you can think about how these two things combined are going to be electronegativity, which is a measure of how much an atom wants to pull electron density away from another atom. So if we think about electronegativity as a periodic trend, we can just draw our nice periodic table here, and let's separate it into quadrants. So if we think about the upper right-hand part of the quadrant, well, this is where we're going to have high electron affinity and high ionization energy. So we're also going to see high electronegativity here. And in contrast, in the lower left-hand part of the periodic table, these two quantities are low, so also what we're going to see is low electronegativity. And if we talk about what's going on in areas or with atoms that have high electronegativity, and we think about whether they're electron donors or electron acceptors, what would you expect for an atom that has high electronegativity? Is it going to be an electron donor or acceptor? Great, yep, it's going to be an electron acceptor. It wants to accept electrons, it wants to accept electron density. So in contrast, if it has a low electronegativity, this then is going to be an electron donor. All right, so it's very common to talk about electronegativity of different atoms, and you can look up tables of these. Often what you'll see is not a table based on this definition, but something that's called the Pauling definition of electronegativity. But it's exactly the same idea and the same trend as this more numerical way to think about what the meaning of electronegativity is.